This time, I'm going to compare Bachelier and Black Scholes model. The Bachelier model, also known as Brownian motion model, was invented by Louis Bachelier in his thesis The Theory of Speculation, which was presented in 1900. This model is considered to be the first mathematical treatment of the concept of Brownian motion, which refers to the random motion of particles suspended in a fluid, and it forms the basis for many subsequent studies in the field of mathematical finance. You can see this Bachelier model has a long history and it is very important in mathematical finance. The Bachelier model assumes that the underlying asset follow a normal distribution rather than a log normal distribution as in the Black Scholes model. Let's take a look at the assumptions of Bachelier model. First, the model assumes the price of the underlying asset follows a random walk, meaning that future prices are unpredictable and uncorrelated with past prices. 2. The volatility of the underlying asset is constant over time. 3. There is no transaction costs or taxes associated with buying or selling the underlying asset or options. 4. The options are European options. 5. The risk-free interest rate is constant and known over the life of the option. 6. There are no arbitrage opportunities in the market. 7. Investors are rational. These assumptions are designed to simplify the calculation of the fair price of the option and to provide a theoretical framework for understanding how the price of an option is determined in a market with rational, risk-averse investors. Because Bachelier model has those assumptions, you can imagine there must be many limitations for Bachelier model. First is assumption of constant volatility. This is not realistic, as volatility tends to fluctuate over time in response to changing market conditions. 2. No consideration of dividends. 3. Only applicable to European-style options. 4. Assumes no transaction costs. 5. Cannot explain volatility smile. 6. The Bachelier model is only suitable for pricing relatively simple options, such as plain vanilla call and puts. It's less useful for pricing more complex options, such as exotic options or options on assets with multiple sources of risk. So overall, the Bachelier model is a useful starting point for pricing options, but its limitations mean that it is not suitable for all applications. More advanced models such as Black Scholes model or the binomial option pricing model have been developed to address some of these limitations and provide more accurate pricing for a wider range of options. This sounds like we don't need Bachelier model anymore. But when we think about the limitation of Bachelier model, we should also think of the limitation of Black Scholes model. Then, what is the limitations of Black Scholes model? First, assumptions about the underlying asset. The Black Scholes model assumes that the underlying asset follows a log normal distribution, which may not always be the case in reality. Remember, Bachelier model assumes the underlying asset follows a normal distribution. And also Black Scholes model assumes that the underlying asset has constant volatility. Secondly, the Black Scholes model assumes that the underlying asset price cannot be negative. This is because the model assumes that the underlying asset price follows a log normal distribution, which is a distribution that only allows for positive values. This is a very important point when we compare Bachelier model with Black Scholes model. 3. Market efficiency. 4. Limited to European-style options. This is a similar limitation with Bachelier model. 5. Ignores transaction cost and taxes. 6. Assumes constant risk-free interest rate. 7. Cannot explain volatility smile. Again, this is the same with Bachelier model. 8. The Black Scholes model is not suitable for pricing complex options. Now, let's compare Bachelier model and Black Scholes model. There are 3 big differences between those two models. First is distribution assumption. The Bachelier model assumes the price changes of the underlying assets follow a normal distribution, while the Black Scholes model assumes the logarithm of the price changes follow a log normal distribution. In the normal distribution, prices could take any value from negative infinity to positive infinity, including negative prices. In the log normal distribution, prices cannot be negative. At the beginning, this normal distribution, because it allows negative prices, it was considered as a limitation of Bachelier model. Second point is dividend assumption. The Bachelier model assumes that the underlying asset pays no dividends, while the Black Scholes model allows for the payment of dividends, which can affect the value of the option. In fact, the original Black Scholes model also doesn't allow payment of dividends, but the Black Modern Scholes model improves that, which allows the payment of dividends. The third point is the Bachelier model tends to underestimate the value of options, while the Black Scholes model tends to overestimate the value of the options. This is because the Bachelier model assumes a normal distribution, which has a thinner tail than the log normal distribution assumed by the Black Scholes model. I wrote a program to evaluate options with Bachelier model and Black Scholes model. Later, I will show you the valuation result. From my program, you can see the Bachelier model underestimate the value of options and Black Scholes model overestimate the value of the options. As I mentioned before, Bachelier model has a long history, which means it is very old, and also Bachelier model allows negative asset prices. And at that time, it was considered as one of its limitations. But ironically, the model gains attention again in the 21st century because it can deal with negative asset prices. The spread of COVID-19 led to lockdowns worldwide and an extremely sharp drop in the global demand for oil. In April 2020, the price of oil future contracts became sharply negative for the first time in history. In response, CME and ICE temporarily changed their model for oil and the natural gas options from the Black Scholes model to the Bachelor model until August 2020 to handle the negative prices. When I prepared for making this video, I mainly used two papers as my reference. One is this paper, How Close Are the Option Pricing Formulas of Bachelier and Black Scholes. And another one is a Black Scholes User's Guide to the Bachelier model. You can search the internet and download the paper and read them, and you can learn more details. Now, let's compare the formula of those two models for call options. For the Bachelier model, you can see we calculate this D first, and then we will calculate this call option price. And Black Scholes model, we calculate D1 and D2, and then we will calculate the call option price. And ST is current stock price, K is the strike price, R is risk-free interest rate, and sigma is the volatility of the stock. T is time to expiration of the option. And capital N is cumulative standard normal distribution. All those symbols are the same for both Bachelier model and Black Scholes model. In Bachelier model, we also use density function of standard normal distribution, which I use lowercase n to represent it. We just compare the call option pricing formula between Bachelier model and Black Scholes model. Also, I have a formula for the put option price for the Black Scholes model. For the Bachelier model, I calculate the call price first, and then I use put-call parity to calculate the put option price. Now, let's go to Python to compare Bachelor model and Black Scholes model. This is formula for the call price with Black Scholes model, and this is the put price with Black Scholes model. For the Bachelor model, I only have this formula for the call price. When I want to calculate the put price for the Bachelor model, I will use this put-call parity to calculate that. And now, time to expiration is 1 month, and sigma is 0.2, and strike price is 105. Risk-free rate is 1%, and I'm going to change the stock price from 90 to 110 and divide it into 100 units. Now let's calculate the call price and the put price with both Black Scholes model and the Bachelor model and compare them. You can see the top graph is showing the call price and the bottom graph is showing the put price. And this blue line is Black Scholes model price, like this, and the red dot is Bachelor model's price. And you can see this is call price goes up when the stock price goes up. And if it's put, you can imagine the put price will go down when the stock price goes up. Now you can see both models give us very consistent price. Now what will happen if we change this time to expiration? For example, if we change it into 2 months, you can see it shows difference. And obviously, the call prices shows larger difference than the put price. What happened if we change this time to expiration to 6 months? So it's half year. You can see the difference became larger between Black Scholes model and Bachelor model. And as I mentioned before, the Black Scholes model turned to overestimate the price for the option, and the Bachelor model turned to underestimate the option price. This is true for both call option and put option. Now, if we put time to expiration back to 1 month, and then we change the risk-free rate to 5%, you can see it also shows difference for the call price when the stock price is high, and also similarly shows larger difference when the stock price is high for this put option price. I will upload this Python source code to my GitHub. Then you can download it and change all those parameters and try it by yourself. This is my comparison between Bachelor and Black Scholes model. Please provide your comments and subscribe to my YouTube channel. Thank you.